Hi, I'm going to speak a little bit today about Tycho Brahe. Tycho Brahe was an astronomer who, although didn't have a telescope, he made a huge impact on astronomy through his observations of stars and planets, and specifically the positions of stars and planets. In the late 1500s, he had an observatory on an island in Denmark, and he had some number of assistants. He had an excellent device for measuring positions of planets, which is shown here, and the observer would be here and looking at the star, and this observation would take place right as the star or planet was reaching its highest point in the sky, which is what we call the meridian. The meridian is the line in the sky going from the north point to straight up overhead to this very south point on the horizon. And this is basically defined as we see stars move up to this highest point and then move down, just as the sun gets to its highest point at noon, local noon, and the stars do the same thing. And he was able to take the timing of the meridian crossing of stars as well as the position in angle at the time of meridian crossing to develop a very good measurement system for planets and stars, and in particular he had excellent observations of Mars, which were later used by Kepler to derive 3 laws of planetary motion. And so this again before the use of an actual telescope to see what the planets look like up close. So the idea of what a planet is and a definition of a planet here was the same as in ancient times, that just lights in the sky moving, and they had complicated motions, and the goal was to try to understand those motions. And so Tycho found, first of all, that Ptolemy's description of the motion of the planets was not accurate. If we look here at Ptolemy's description of the Earth and the Sun and Mars on the right, with the epicycle, which is not shown here exactly, but the effect is here where Mars does this retrograde motion and loop backwards as viewed from the Earth. The Earth is a blue dot in the center, not moving. The Sun is orbiting the Earth in a circular orbit, and Mars is orbiting Earth on an epicycle moving along a circle. And Tycho realized from his observations that this model just wasn't working right. He was attempting then to see if the newer model by Copernicus would be the correct model, and that has the Sun here in the center and the Earth and Mars orbiting in circular orbits. And probably much to his dismay, he found that this model didn't work either. There were errors in both models in terms of their ability to predict the positions of the planets in the sky. And so his solution to this was an attempt to reconcile both of these things, and he thought about the fact that geocentric model of Ptolemy and Aristotle was philosophically very appealing, and provided also an explanation of, well, we don't feel like we're moving, so there was maybe a different way that he could describe a situation where you had the Earth not moving. But he did like the idea of the heliocentric model of Copernicus, that the planets are orbiting around the sun, and he didn't really accept the idea that the Earth could be a planet, which is what Copernicus had here. So his model, the Tychoan model, could be described as a geostationary heliocentric model. That means the Earth is stationary, not moving, just like Ptolemy's model, but it's heliocentric because the planets orbit around the sun. So we see the Earth here not moving, the moon orbits around the Earth, the sun orbits around the Earth also, but Mercury, Venus, Mars, Jupiter, and Saturn are all orbiting around the sun. And so the effect is a complicated motion as seen from space, where you would see the motion of the planets looping around. From the Earth, this would appear, it turns out, also very similar to what we see at from the observations at night. In fact, it's remarkable how that with the refinement and determining exactly the speeds of the planets in this model, that he could predict practically as well as the Copernican model, as well as Ptolemy's model with epicycles. These three models were all sort of equally good and equally poor at predicting the positions of the planets. More or less working for a while and then failing as time went on. So there needed to be a new model that really described the orbits in a precise way that could give real predictions of how well the planets could orbit around the sun. And fortunately, the thing that Tycho provided was a lot of data, because his observations of Mars, especially, and other planets, were used after his death by his assistant Kepler, who then ultimately solved the problem by developing 3 laws of planetary motion, and basically solved the problem of being able to predict the planets very precisely for a long time, with the exception of Mercury, which had some deviations seen over a long period of time. Kepler's laws worked extraordinarily well in determining the positions of planets for many, many years into the future.